All right. I really like this argument and the proof that you can do to prove it. It's actually it's pretty satisfying because it follows, if you follow the tips of constructing proofs, it becomes pretty cool. So, where you have one premise and one conclusion, and notice really the only difference is where the parentheses are. We're trying to prove you got if F then G then H. From that premise, we're trying to get if F then if G then H. Well, let's try to prove it. Remember one of the tips for constructing proofs, I think it's tip 11. If you're trying to prove a conditional, use conditional proof. This is a conditional, so let's try to use conditional proof. This is going to be our strategy. Since we're trying to get this conditional, we need to show that if F, so if we assume F, then we can get if G, then H. Awesome. Now, how are we going to get if G, then H? Well, you're not done with your tips for constructing proofs. Just because you're inside of a box, we can use tip 11 again. We're trying to get a conditional, and a good way to get a conditional, according to tip 11, is to do a conditional proof. Since we're trying to get this conditional, if G then H, we could do another box inside. We're trying to get if G then H, so we'll assume G. So if G, we don't know if G is true, but if G, we're going to try to prove H from that. So we make this assumption inside for CP. We're going to try to get H somehow. If we get it, we've shown that if G then H. So we can write if G then H. And once we get that, we've shown if we assume F, if F, then if G then H. So that's our overall strategy. Let's go ahead and try to do that. So in order to get this conditional, we're going to assume F, the left side of the arrow. And we want to get if G then H somewhere in our box down here. That's our goal. And since this is our goal, right? This is our goal. You want to hit the bottom of the box. We can do a conditional proof to get it. Because if we assume G and we can prove H, we'll get it. So let's start another conditional proof inside. We can't forget our annotations. So this is assume for CP, and this is assume for CP. Now inside this inner box, we want to get H. How are we going to get H? We have three things to work with. Premise 1, and then line 2 and line 3. How are we going to get H? You might go through various of your tips. You might go through different rules. Try to think of what's equivalent. That might be a long road. Here is where tip 12 is going to come in handy, where it looks really difficult to get what you want. Sometimes it's a good idea to do reductio ad absurdum. So the idea here is we want to get H. So if we can show that the opposite of H leads to a contradiction, we'll assume not H. We can show that leads to a contradiction. Well, anything that leads to a contradiction has to be false. So if not H is false, that means H has to be true. So we'll do not H as an assumption for reductio ad absurdum. We're going to try to show that not H is false by showing that it leads to a contradiction. Can we do that? Well, now we have something nice to work with. We have not H, which is the denial of the right side of this conditional. That's the main connector. So when you deny that, we're going to get from 1 and 4. That's going to be modus tollens, and that'll result in the negation of the left side, which is going to be the negation, and don't forget your parentheses, because this is going to be a negation of the entire left side. Sorry, I don't know why I wrote L. Probably because I said left. So if F, then G. Right? So the negation of the left side. Now we have this conditional that's negated. What can we do? Well, a good tip that I often mention is that I don't like when you have a negation of something more complex inside parentheses, because that's very hard to work with. There's not a lot of rules that can make direct use of that. The implication rules, occasionally there is, but usually there's not. So I like to get rid of that. I previously shown you how to get rid of something where you have negation out front and you have a V, a disjunction, and that takes 1 step, De Morgan's. But when you have an arrow in there, it's going to take 2 steps. So first, you're going to want to change the arrow to a V, which is going to be through material implication. So you're just going to apply material implication to the stuff inside the parentheses and leave this stuff alone. And there's 2 things you do with material implication, right? You change the arrow to a V, and you add a negation to the left side. So that's going to be not F or G. And now, because you have a V in there, you can apply De Morgan's to get rid of this negation outside. And that's a nice combination. When you have something like this, a negation of a conditional, remember that you can use this combo. Use material implication and then De Morgan's. When we apply De Morgan's, we do 2 things. We distribute the negation to each side of the disjunction. So we add a not to the not F. So now we have 2 nots. And we add a not to the right side. So we have not G. And we flip the V to a dot. If this were a dot, then we would flip the dot to a V down here. Whatever it is, a dot or a V, you flip it to the other one. All right. Still trying to get a contradiction. Now I have this nice conjunction. And of course, when we see a conjunction, we should remember that we can pull out each side by simplification to get each side by itself, which is much easier to work with. Usually the smaller the statement is, the more things you could do with it. All right, can we get a contradiction? Well, F is going to be equivalent to not F, right? Double negation. But look at that. We got G up there, and we got not G there. Perfect. Perfect for a contradiction. So let's do that. Put them together. G and not G. So 3, 9. Conjunction. We can join them. So now we've shown that if we assume not H, that leads to a contradiction. That's absurd. We've reduced not H to absurdity. So that means it's false. And if not H is false, then from 4 through 10, reductio ad absurdum, we've reduced it to absurdity, so that means the opposite of it is true. All right. And now, remember our strategy. We are going to assume F and try to get if G then H. In order to get if G then H, we are going to assume G and then try to get H. So we'd show that if G then H. And now we've done that, if G then H. So that means we can close out our middle box, the second level. And we can conclude if we assume G, then we get H, which is 3 through 11. Conditional proof instead of reductio. And now, following the strategy that we mapped out, once we get if G then H, we've shown that if F, then we can get if G then H. And of course, remember to put your parentheses there correctly. And that's going to be 2 through 12, conditional proof. We have to remember number our 1, and we close out this outside box. And we've gotten the conclusion we were looking for. Now, for some of you, this proof might be very satisfying. For others, it might be very frustrating. But notice what I did. I followed the tips. I followed the rules. It might not be obvious to you what in the world strategy you should use to get this from this premise. But if you follow the tips, especially tip 11, using conditional proof to get a conditional, then that'll give you a nice start. And so you can map out your strategy, and then once you got stuck, because remember, from G, we were going to try to get H somehow. And it was not very clear how to get H, which is a perfect opportunity to try reductio ad absurdum. So let's reduce the opposite of what we're trying to get, H, which is not H. We're going to try to reduce that to absurdity by showing that it leads to a contradiction. If not, we assume not H, then it's a contradiction. So it has to be false, which means its opposite is true. And then we worked forwards through the reasoning we had previously worked through backwards. All right. Awesome. I hope you enjoyed that proof. I enjoyed that one.